Good afternoon, and welcome to today's webinar on the topic of factory automation technologies for automotive applications. Today's presentation will be given by Jason Dubey. Jason is a CNC application engineer with over 5 years experience in the machine tool business of Siemens Industry. His main focus is technical support for machine tool and motion control OEMs, and he specializes in automotive applications that are not only CNC, but also how CNCs integrate into automation and entire factory networks. Jason works closely with the Siemens Automotive Group in Detroit to design line architectures, to create CNC solutions, and to support new applications. So without further ado, welcome Jason.
Okay, thank you, John, and thank you everyone for attending. My name is Jason Dubey. I work here in Detroit for our group in Elk Grove Village. My main responsibility, like John said, is support for CNCs, but because of the area that we're in here in Detroit, that doesn't mean that it doesn't not involve the automotive customers, automotive OEMs for CNC and standard motion control products or systems. A lot of what I do is working with our OEMs, setting up machines that are going to our automotive end users. Also working with the group here in Detroit, our automotive group, to create solutions with them or create line architectures like John mentioned, and to understand what the automotive factories would like from our products and integrate into standard factory automation, PLC, or other systems that they might have on the floor already. So what we're going to discuss today within our presentation is what is totally integrated automation, or TIA. This is the fact that I want to really stress in the presentation. This is a marketing slogan from Siemens, and it shows how all of our components, whether it's a PLC-based component, a CNC-based component, a standard motion control, or a high-end motion control product, all integrates together seamlessly with the same software products or same basic hardware architecture. What I hope that everyone understands at the end of the day is whether you have a PLC-based system, you're an engineer that specializes mostly in simple factory automation products, or you're a high-end CNC specialist. Either one of those engineers can seamlessly transfer to the PLC or to the CNC world and program their automation components without any level of learning. For the most part, they're the same products, the same software. They're just in a different piece of hardware. So because I am in the CNC business unit, the NCU, or our Sinumerik 840D product, our CNC is the product that I will be focusing on mostly today. I talk about our current product, which is our NCU 0.3, and also our current software level release with that NCU. So I'm just going to go over the hardware structure of that component and what it contains inside of it. I'm then going to kind of make up a system just like an automotive end user would make up. They would try to design their factory plant network using our components or other components to not only protect and secure their network, but also to communicate to simple automation components like I/O, cameras, or RFID. We also are going to communicate to other CNCs or other CNCs using the different forms of interlocks. We're going to look at what we've had in the past, what we used to use, and what we currently are using, newer technology. And we're just going to show that we can do that with standard interlocks or fail-safe interlocks. And also kind of reiterate the fact that this is totally integrated automation. So whatever we do today, focusing on a CNC, is exactly the same with a PLC. So to start off with, we're going to look at our Sinumerik 840D controller. This is the NCU 730.2 or 0.3 PN. The 7XO stands for a possibility of having a 710, which is our lowest access limit, to up to a 730.3. All have the exact same components inside of it. It's just how many CNC axes you can do with it. But for the most part, this is going to be the exact same for each of these. And inside of this NCU that we talk of, or we show on the screen, contains several components, one of which is the NCK. This is the intelligence of a CNC operation. We also have embedded is a PLC, the exact same PLC that you would find on a standalone automation system. This is nothing different than a regular PLC you can get from a distributor. In our case, inside of our NCU, we have a 317.3 PNDP inside of this controller. We also have a drive controller board. If anybody from the motion control background is familiar with our control units, we have kind of a distributed drive setup, but it all controls. It is all controlled by a central drive controller unit. This we find already inside of our NCU. We also have a running HMI system running off of an embedded Linux operating system. This HMI allows you to program your own custom screens, or simply to use the standard out of the box screens developed by Siemens for simple to complex machine tool, job shop, or automotive control. And then, like I mentioned, this is running on a Linux embedded operating system, which we find here inside the NCU, and with every operating system or every PC-based system, we have a flash memory storage. Now, that's equivalent to something you would have on a Windows-based system. This, of course, is all embedded, all contained in this one unit. It operates similar to just any PC that you've had in the past, but it contains a lot of the components of it, but is a lot simpler to operate and to program. So having said all that, those are the major components. We have components that we can control off this main NCU, like our operator panel you see here on the left-hand side, with a machine control panel, which is nothing more than just standard I/O. We have our drives that we control, standard and safe Profinet I/O, also standard and safe Profibus I/O, and if we needed to control regular drives, analog axes, or hydraulic actuators. These are all components that this NCU will communicate to. So inside of a typical automation system, we have several components that are necessary, that make up the system. Like I said, we have a PLC that's usually the intelligence, the center of your automation station, with the progression with end users looking to make their machinery more safe for their operators to use, and also to prevent different machine crashes or technical issues that could run into. We're seeing customers move towards a fail-safe logic controller, whether that's in the form of a PLC or some sort of safety relay system, things like that. But that is usually an essential element to a new automation system. We also have the need for communication processors, sending large amounts of data up to a factory network. some sort of control of rotating drive systems, whether it's a speed or position or even a torque control of a conveyor system possibly. You're always going to have an HMI, some way to interface the operator to your automation system. And then the storage for any log files or possibly data that you want to save, for example, recipes or alarm logs, data history, things like that. Those are all the necessary components you typically see. Now with an NCU or an 840D controller, we have all of those components contained into one unit, one part number. It's all there. So if you need it, you can tap into those functions. So we have, like I said, our PLC. We have the NC is an NRTL listed fail-safe controller. So from the NC, we can program fail-safe logic to control fail-safe I/O right from this unit. We also have a built-in CP card, and like I mentioned before, our drive controller unit is inside. We have endless opportunities or possibilities to expand the HMI. That's already in there, but by default you have the Siemens generated HMI, which is usually good enough for 95% of applications. And of course we have flash memory storage, so if you need to save alarm logs, you don't want to worry about the flash or the RAM memory being lost over time. You can store that right on a flash card itself. So those are the typical components of automation stationing. You can see that we have all of those components, plus obviously one additional one, which is our intelligence to the CNC system. So we have three ways we can communicate to this NCU and to get into all of those components that I described in the slide before. We want to access not only the PLC to change ladder logic or to edit the hardware or I/O, but we also want to add information to our CNC, or we want to tweak what we see on our HMI screens, or communicate data to our CP card, or write or read data from our flash storage. We can do that in one of three ways, or one of three ports, all Ethernet driven, but we have our first one, which is our X120 network, our thin client, our HMI network. Typically on this network, you may have a programming port, you may put your PC into it, but it's more or less Sinumerik or Siemens components that sit on this network that don't leave the machine, because this is a network that is going to be duplicated from automation station to automation station. So you're not connecting this outside of the machine environment. This does not leave the factory or leave to the factory. It stays right at the machine. We also have our X130 network, our factory network, which will go up to the factory communication servers or information servers. What I see typically in automotive is we will put our programming ports on here. Customers are looking for their staff to be able to plug into a programming port in their facility and to get on any device or any NC, PLC, automation component they want to be able to talk to through this one programming port. This is a way to do it through this X130 port. We can assign a unique IP address to each automation station, including this NCU, and put that onto a common network. And then the third network that we can connect to for programming is what's called our service port. This is more or less a dedicated programming port for our NCU. We can eliminate all switches, all 24-volt components, all networking cables. We can bypass that and plug right into the unit through this port itself. Three different options, both X120 and X130 typically have components sitting on them, and all three offer each an individual benefit, but also the same data is accessible all through all 3 ports. So what I want to do throughout this presentation is we're going to assemble a system or design a system just like an automotive end user would. Typically he has his plant network, and we're going to connect each automation station or PLC or control to that plant network. And by plugging just a regular PC into this plant network, we want to be able to access each device. And that's what I've done here. On the left, I've shown that we have a CNC machining station using one of our NCUs. And on the right, we have a typical standard PLC that you would get from Siemens, also plugged into this plant network. So on the left side, this may be a little bit new for some people, but this is our NCU, and it differs not by any means from the PLC that we see on the right-hand side. And during the slideshow, I'm going to show that the left and the right are exactly the same. There's absolutely no difference to our system design, but all components of a typical factory system. Okay. Now we've talked about different ways of communicating to our NCU or to our automation station. They're all Ethernet driven. We've connected that to our plant network, but we want to make sure that we can protect that network. We don't want access to that network from outsiders, whether that's outside the plant or on outsiders that don't have the correct permission or security to get into our network to see the information. We want to restrict that. We want to secure it. So we're trying to prevent espionage or, like they say, data manipulation. This is a very serious issue to most companies. And what we can do is we can put on different Siemens products, standard automation products or standard factory automation components to secure or put our factory network behind or a machine network behind a virtual private network or a VPN. So we have 3 or 4 different components that we can use to secure that network. What we're going to be focusing on mostly is customers trying to access from their home base or wherever their OEM facility is through the internet to the end user. This is the most typical situation. They're going to be doing this over the internet, and they want to get into the Sinumerik or somatic controller, whatever one is their preference. So we have a few different ways we can do this. One, we can go right from a router to another router. Router A sits inside the customer's facility, and router B sits inside the end user's facility. This is one possibility. If the router is VPN capable, then in each router exists a VPN, and you have to work with the router producer, the manufacturer, to secure this tunneling from one system to another over the internet. The second option is using on the PC at the OEM's customer base is using the SoftNet security client, and at the end user we put a scale and security module. So by doing that, we can tunnel from our PC through the internet, which is a dedicated protected tunnel right into our scale and security module, our VPN capable security module. Okay, this is a protected tunnel that can't be accessed by outsiders. This is a way of making sure that that connection is secure and allowing the end user to understand that outsiders are not able to get into this without the correct secure ID at the client side. So the third option is similar to the second, and that's putting a security module at both sides, one at the machine tool builder and one at the end user. So you have a typical PC at the machine tool builder. You connect to the security module, and that forms a tunnel from one to another to the end user and then into their factory network. So what you have on the PC is you just have your simple Step 7 programming software to program the PLCs, but you want to be able to dial into these modules. This scale and security module is going to allow you to form a secure path to do that. But once you're in, it's simply like a point-to-point connection, just like you're at the machine, and you can then program the PLC or look at the HMI, things like that. So here's a typical scenario. That's scenario 2 that we just described. You have the client software sitting on a PC going through the router, a dedicated path on the internet that's secure through router B into the machine network through our VPN or scale and security module. Okay. Once you're inside that automation cell, you can jump from automation cell to automation cell because you're guaranteed to have the right credentials to get into this network. That's a very important piece of hardware because we're not only trying to help end users protect their networks, but we're trying to keep all the correct information inside their network so their data is not getting out, but also trying to prevent data manipulation to avoid possible crashes or downtime. And nothing may leave the facility, but if a machine cannot run, that's bad for everyone. So 3 different options that we had there. So back to our system design that we've had, we simply have the exact same design as before we started talking about the security module, but we simply added our security module here. And our PC is now not connecting directly into the plant network, but connecting through the internet, whether the machine tool builder's next door or next country over. It really doesn't matter in this point. So moving on into the next area that we're going to talk about is our NCU, or machining centers, controlling simple automation components. Our first and probably our most commonly used automation component is our machine I/O. What options do we have from Siemens, and what do we offer up to be controlled from the Sinumerik 840D from our CNC? We have a wide range of components to suit your needs. Different I/Os serve different purposes. We have 4 of the I/Os that you see on the screen here that are safety rated, which mean we can get Profi-safe or safety capable inputs and safety capable outputs on both our ET200S and ET200M, which sit inside the cabinet, and also the I/O that sits outside of the cabinet, whether it's rack-based, like our ET200 Pro, or module-based, like our ET200 Eco. So we have a wide range of I/O and even ones that are capable of producing our safe I/O, which can be controlled either by our fail-safe PLCs or our CNC. Just recently, we've released a new, a new line of I/O, which is our Sinumerik ET200SP I/O. We currently have the ET200S. This is slightly different now. We have a smaller, a footprint than the ET200S we had in the past. We have a couple advantages of using this. One, with the ET200S, we never had the capability of doing 8 or 16-point I/O, I should say. With these modules, we do have that possibility. We have 16-point input and 16-point output modules. We also have something a little bit unique to the system, and it's power modules that are integrated right into the terminal blocks, or the base unit is what we call now. Instead of in ET200S, we had a dedicated power module and its associated terminal block. With these modules, we have some terminal blocks or base units that are white in color, which stand for the beginning of a power group, and then we have some other colored power or terminal blocks that stand for getting its supply voltage from the component to its left. So we can break up the power groups simply by changing our terminal block or our base unit, as opposed to adding and purchasing a separate component. So we've reduced the number of components that our customers have to purchase, and we've also eased the ordering process. So it's making it a little bit easier, less components, less possibility of errors or misordering. So one of the nice features about these I/O modules is that we have kind of a tool-free connection system, is what they call it. If we have a wire or an input that we have to push into our module, we can simply push that into the terminal itself without the need for a screwdriver, without unscrewing a terminal and pulling out the wire and then screwing that terminal back up. We can simply push it in without any need for a tool, any need for releasing a spring-loaded mount, and the wire will simply go in. Now, this also means we can separate components from one to another by simply pushing on tabs, as opposed to in the past using a screwdriver and separating the I/O from one to another. So a few of the features of this A200SP are made for quicker installation, easier installation, and simpler installation. So those are a couple of the features now with these E200SP I/O, and again, this is new to the market, but because we have a standard or similar platform to the regular PLCs, we do support this on our 840D SL controller. So this is now an option over Profinet. With every automation station, you typically need some type of motion, whether it's positioning motion, whether it's just standard turning on a motor, controlling the speed of that motor. If it's a conveyor system, on and off is simple enough, or if you want to vary the speed, or a rotary table, for instance, on a conveyor system, you might have to realign the part, or invert it or flip it upside down. These are all common tasks that machine tool builders are faced with. We have a wide variety of drive products in the Sinumerik umbrella. Different ones that sit inside the cabinets that are speed-based, that are positioning-based, that offer simple VFD control, or very large chassis-sized drives that offer high power, high torque, power motor or current motors, or things like that. One of our new products that we offer is what's called the G120D with positioning. The G120D has been around for quite a while, and what it is a decentralized drive, the D in the name. We mount this drive or this inverter right onto our conveyor system. No need for a cabinet. No need for additional wiring out to our motor. We simply mount the drive right at the location of the motor and connect our motor directly to it, so that we've limited the amount of cabling and eliminated the need for any enclosure, things like that. What we now release is the fact that this drive will now do positioning. So if we have a simple turntable or an elevator station quite far away from possibly our Sinumerik machine tool, then we can simply connect and control this drive positioning over either a Profibus or Profinet network cable. So this drive is not only positioning control, and if we needed speed control, but we can also control safety functions directly in this drive. Standard safety integrated functions like safe torque off, where we can safely know that the drive will not fire the motor, or safe operating software, safe limited speed, things like that we can do, we can control on this drive without the need to hardwire it. We can do this all over that very same bus that we communicate from our CNC to this drive. So multiple purposes of control, enabling communication for speed and positioning, but also communication for safety enabling, can all be done through our bus from either our PLC or our 840D to this drive, and to many other drives in the Sinumerik umbrella, like the S120s or G120s, along those lines. So distributed drives or standard cabinet-based drives are all devices that we are able to communicate to. Now, probably the last component that we're going to talk about with automation components is standard RFID, industrial identification systems, like RFID units or barcode or data matrix readers. These can be brought back right into our I/O system, our Profinet or Profibus systems directly. We can read these data that are on an RFID tag. A simple example of what we use in automotive is an RFID tag stays with the pallet every time a part goes into a machine. We machine it and then update the tag with information. And that tag stays with the part through its entire life of machining. We also have a barcode or a data matrix scanner that similar application, but a kind of a different concept. We have a matrix on the part. When that part comes in on a pallet, we read the matrix, but then we access either a main central PLC or a server for the information on that part to figure out what it's been done so far to it, machining steps, and once we machine it, we basically update the server, which is referenced through that data matrix code. So all these different components, I/O, regular I/O, safe I/O, regular distributed drives or safe distributed drives, regular cabinet-based drives, industrial identification systems, all can be communicated to through two different systems, our Profinet I/O system or our standard Profibus system, all connected to the front of the NCU or on a standard PLC-based system to a regular PLC. So back to our system design, we've simply added now to our NC the communication, regular communication to our ET200 I/O, and also safe communication. One connector, one cable, one Profinet cable from the control to the I/O, but serves multiple purposes. And then on to our RFID and our distributed drive. We've also done the exact same thing on the right-hand side for our standalone PLC-based system. So I think the last step we all see coming is how are our PLCs going to be communicating with each other? And this is obviously a major task that each automation or each machine tool builder is faced with, because a lot of times it's not the machine tool builder interlocking with his own hardware. It's to other customers that they have to interlock or share data with. So this tends to be quite a bit of a process, and typically is only done at the end user. When the machine is finished, all the interlocks are jumpered out or somehow disabled, and when the machine gets to the end user, there's quite a bit of work involved to get these interlocks working. So we're just going to look at the evolution of interlocks and what we do on a Profibus system, what we've done in the past, and what we currently are doing. So on a standard system, you have an NC and a PLC, or two PLCs or two NCs. And we have our safe I/O or regular I/O. Safe I/O could be in the form of an e-stop, wired into one control. Now we want to pass that e-stop or that safe signal to the other PLC to let it know that we've pushed that e-stop and that station should go into a safe state. Or we want to pass a regular interlock, like start that system from one station to another. And in the past, we've always had to hardwire these from one I/O module to another. Okay, so we've had to duplicate wiring. Anytime we have a safe e-stop, we've had to wire it into not only the local I/O, but also pass that signal onto the other station. And then, of course, he has to pass signals back and forth. And this is a hardwiring interlock circuit. This is quite labor-intensive and quite expensive. So we've progressed away from that to a better solution, but not the final solution. We've tried to do everything not through duplicating wiring, but through automation components. Like, for example, on a Profibus network, we use a DP to DP coupler. This is a component that we can configure on two networks, and inside of it pass data from one network to another. So for our safe and regular interlocks, we go from our network on our NC side to the DP coupler. That data is passed through to the DP coupler to the other automation station, which is our PLC station. A great solution compared to what we had, because we don't have to duplicate wiring anymore, but we still require us to purchase a DP to DP coupler. So we're not quite satisfied yet. And that brings us to our last solution with Profibus, which is a master-slave solution. So we set up one system as a slave, for example, our NC, and we communicate our data over the bus cable to our PLC without the need for duplicating wiring or the need for additional components. Okay. So this is what we've had with Profibus, and our final solution is the greatest solution because everything is software-driven. Everything can be done through email communication from one machine tool builder to another, and as a setup. And once we connect our systems at the end user, it's simply a connection of a Profibus cable. Now we're slowly moving to the Profinet network in the CNC world. I think in the PLC world we've already aggressively moved to that solution. But in the CNC world, we're really starting to make a push for it now, and we need that similar solution in the Profinet bus world, and that's what we have here with our new function called iDevice. This has been around for a little bit with standalone PLCs, and now we do this with an NC just because it is exactly like every other standalone PLC or NC. So what we do is we define one CPU as an I/O controller. In Profibus terms, we used to call it a master. And we define a second CPU as what we call an I/O device. And this is basically the way we're going to be communicating from one CPU to another is through software, but using these iDevice functionalities. So we're going to pass regular interlock data, but we're also going to pass safety interlock data through this I/O controller, I/O device setup. And what we do in the I device is we designate an I/O, an input address area and an output address area, and we simply generate a GSD or a basic piece of information for the CPU or the I/O controller that we can simply drag onto their network just like we would with any other I/O module or third-party Profinet or Profibus compliant module. We would simply drag that GSD onto that network and we would be able to communicate. All the communication would be set up. We would have the I/O address lengths already set up inside that module. That's essentially what we're doing with the I/O device, but it's all software driven, all connected and set up through step 7. So back to our evolution of interlocks here. We have in Profinet, we have our standard hardwired interlocks, nothing great. And then we transitioned from a DP to DP coupler to a PN to PN coupler. We still needed that extra piece of hardware, but this is all software based, which is great. But then we have now our I/O controller, I device, and we do this all over one connector, one cable, no additional hardware, and no reason to redundantly wire our e-stops or our simple interlocks. And that's really the key. Less wiring, less setup, less hardware, and easier installation is what we're trying to show with this I/O controller. Now to take it one step further, we also have a function called shared device. Now we have 2 I/O controllers, 2 PLCs on a system, and we can communicate to different I/O modules inside of one rack based on our configuration setup. This is going to be useful, I think, for longer, bigger machines where you might have split stations or multiple controllers, one at one end, one at the other, and I/O devices shared or I/O points shared between the entire machine. Instead of purchasing multiple interface modules, one for each I/O controller, and then multiple input cards, one for each I/O controller, one for each interface module, we can now combine them all, use the common interface module, and just point to what card we want to communicate to, and tell the I/O controller that you're controlling this card. This card is master is controller 1 or controller 2. So on this example here that we see, we have on the left-hand side we have a fail-safe I/O controller. He's just interested in the fail-safe I/O, and then we have a second I/O controller. He's interested in the process I/O. We've had to purchase an interface module and an I/O card for basically each controller. Now we can move to a new solution with the shared device to combine the rack, but say only one card is being controlled by me and the rest of the cards are being controlled by I/O controller 2. So not as much cabling, not as much hardware, simple to engineer, easier to implement. So I think that's a benefit for everyone. So these are a couple of the solutions that we have with Profinet now. We've had this for a little bit on a standalone PLC system, and now with our newer hardware that we have in our CNC world that's been around for almost a year now. We now have that capability of doing this all through software. So connecting the two systems back to our system design, we connect the two systems simply by one Profinet cable. The cable or communications through that cable is regular or safety interlocks, but we only need to wire up that interlock one time to get it into our system through an I/O module, and then it can be passed from station to station just simply by connecting a Profinet cable. And of course, everything we do with the PLC, we do with the CNC. So if two CNCs had to communicate together, They absolutely could. No additional hardware, no difference in system architecture. It's all pretty much the same configuration. So what I'm going to do right now, that kind of concludes my slideshow. I'm just going to show you very quickly how to configure iDevice on a CNC and communicate it to a PLC. This is all going to be offline, but I think if you can see what we're doing, you'll understand how easy it is, how simple it is, and maybe a possible re-engineer or I guess a simpler engineering for the next stations you do. I'm simply looking at here my NCU. I have my NCU and all its components and a couple of the buses that come off my NCU. I'm going to double click on my Profinet network, and with the newer systems, I now have this iDevice tab. I can make my NC an iDevice and tell it that I want to transfer 1 byte of outputs to the I/O controller, and I want to receive 1 byte of inputs from the I/O controller. So in my PLC logic, if I turn on any of these bits as standard coils, if I turn on Q256.0, that will automatically be sent to the next network, or to the I/O controller. And if I read any of these contacts, I256.0 and so on and so forth, I'll be able to read data that he sent to me. So I'll simply OK that, and I'll save and compile my project. Okay. And with step 7, this requires no additional software option. We just simply create a GSD. Okay. So what I'm going to do is I'm going to say webinar, give it a little bit of a description. August 21st, CNC iDevice, and I'm going to create it. Okay. So what I've done now is I've just simply created my GSD. I can either install it if I'm going to be the one who's installing this iDevice on their I/O controller, or I can export it. I can send it to a customer through email and say, this is my system, here you go, you can work your logic into this. And the benefit of exporting it is not only to allow you to send your data ahead of time, but it allows you not to have to send your PLC project. You can simply send a file and save or protect all the information or all the code or functions that you've written inside your PLC. You can protect that from sharing it with other customers. You simply send the information that they need, and they get a GSD. So I'm just going to install this GSD here, and it goes ahead and it puts it into my hardware catalog. Okay. So I'm going to close this project. That's it for the CNC side. Now I just have to make sure my PLC logic is in there, and I've obviously downloaded this. Okay. I'm going to update my catalog and then close off here and go back to step 7. Now I also have a project. I could have put my I/O controller in the same project. I don't have to anymore. I can put it in a separate project, like simulating a separate machine tool builder. And I simply just have to go to my Profinet I/O modules here on the right-hand side and look at my pre-configured stations. And I should see my different I/O devices that I've generated, or my GSDs that I've created in the last step. And here it is here. You can see the description, webinar August 21st CNC iDevice. So I simply connect that or drag that to my Profinet system, and you can see that my I/O address is already set up. The length and the fact that I'm sending outputs first, which would be the I/O controller's inputs, and vice versa. I've set all this up, and it's ready to go. If I needed to switch these I/O addresses, I could. I just have to make sure they're 1 byte long. So I save and compile that, and that's basically my iDevice setup. So basically, that's my system. So I hope, I think at the end of this presentation, at the end of this demo, I hope you understand that anything you do really in the PLC is seamlessly transferred over to the NC in way of setup. So if you're a PLC automation engineer, chances are you're not going to have too much problems with setting up or debugging a PLC system on a CNC or inside of an NCU. Okay, so that was really what I wanted to show. Everything is totally integrated, and we can, on the CNC side, communicate to many automation components similar to a PLC. So I appreciate you tuning in for the webinar. I think we're going to move into the question phase. If anybody has any questions, and we can get those answered.
That's correct. Jason, there are a couple questions that did come in.
Okay, all right.
Give me a second here. The first question, I use an NCU 730.2 PM currently.
Okay.
Can I upgrade to the NCU 730.3 PM now? Is this a current part?
It is a current part. Yeah, it's been a current part since January, so it's on the market and it's fairly proven out. So I've worked with it quite a bit and I love it. It works well and it only has advantages, the way I see it. So it is a current part, and an upgrade from one system to another would be fairly simple from a PLC standpoint. So.
Okay. Another question. You mentioned that the HMI runs inside the NCU. Mm-hmm. Is it possible for me to customize this HMI?
Yeah, there is. There's actually a few possibilities, 3. What you can do is we have something called Easy Screen, where it's more or less an ASCII-based screen development tool. You use Notepad, and by using our examples and our way of programming, you can create onboard or on built-in HMI screens, accessing different bitmaps or I/O through the PLC or NC data positions, things like that. There's also the kind of the higher up solution is what's called HMI Pro, where it's more of a graphical screen configurator, similar to what we've used in the past with any somatic panel. And then the third possibility is using C++ development tools mixed with Microsoft Visual Studios and Qt compiler. So you have 3 options, and basically with the Qt and C++, your opportunities are endless, and with the Easy Screen, it's somebody without any experience in automation or screen development can easily create these. So we have different mix of solutions.
Okay. The next question that came in, what are my remote connection options if the customer won't allow me to connect my machine to the network?
Yeah, I think this probably pertains to that security module slide that I showed. We have a couple different options. Sometimes end users aren't so willing to give a network cable to customers' machines. They want it kind of isolated. So what we have is we have a teleservice adapter, which basically runs off a phone line, and we connect that phone line into this teleservice adapter, and then the other end we connect that to our NCU over Ethernet. So in a way, the machine is networked through the phone line to either the customer machine tool builder through the end user. We also have a cellular access point, which basically is more or less a cell phone. We have a module. You put a SIM card in from AT&T or Verizon and connect an Ethernet cable to your control, and that's a VPN client as well. So, two different options. Some customers like to have access during the commissioning stage of their machine, and those are two solutions if the customer won't give them a physical internet connection.
Okay. The next question is about hot swapping, and the question is the ET200SP IO able to be hot swapped? In other words, can I change IO cards without powering down?
Yeah, the new IO, you can do that. You can pull modules out with power on them, and you can even configure entire IO racks without the need for a specific module. If one is possibly damaged, or you forgot to order one possibly, you can kind of commission a system with only maybe 80 or 90% of the I/O modules connected. So hot swapping is definitely allowed, and a good way to troubleshoot if you need to, or an easier way to troubleshoot. You don't have to keep powering down and powering up. So yes, that is a possibility.
Okay. Looks like there's two more questions in the, maybe we can fit these in the next 3 minutes before the hour's up. The next question, can I connect third-party vision systems to the Sinumerik 840 DSL?
Yeah, that's possible. Over Profinet, what we do is fairly common is we connect a cable to these third-party vision systems using a TCP/IP connection. So it's coming out of our Profinet processor, Profinet port, but we're enabling the connection or configuring the connection using function blocks as opposed to actual configurations in our software, which allows these configurations to be tweaked or drastically changed quite rapidly. You just simply have to change the logic, and you're either pointing to a different partner or communicating over a different protocol, if it's TCP/IP or ISO on TCP, things like that. So yeah, that's actually fairly easy to do, and definitely possible. Yep.
Okay. And it looks like the last question that has come in, does Step 7 require a license to configure an iDevice?
Nope. Yeah, that's all included in the base software of Step 7. So the newer PLCs run or programmed using Step 7 version 5.5, but no, there's no additional license needed for this iDevice feature.
Okay. Let me check one more here if there's anything. No, it looks like that's it. So that brings us to conclusion. Thank you to everyone in the audience for taking time out of your day to join us for this really informative presentation by Jason. Jason, thank you.
Oh, thank you.
And make sure to join our next webinar, which is on HMI operating areas of Sinumerik CNC. It's this coming Monday, August 28th at 1 p.m. Central Time. To register, go to usa.siemens.com/CNC, the number 4, YOU. And in the left navigation, you'll see a link for webinars, and then you'll be taken to the webinar page where you can register right there. Thanks again, and we'll look forward to seeing you again soon. Thanks very much, everybody.